You know, in medicine, there are some real heroes out there, but one of the most important ones works completely behind the scenes. It's everywhere, from your dentist's office to the cardiac ICU, a single drug that totally changed how we manage pain and save lives. And yet, most of us never even think about it.
Come on, you know that feeling, right? That little sting from the needle and then, poof, everything just fades into this weird puffy numbness? Well, that's the magic we're going to unpack today. The star of that show is a little molecule called lidocaine, and its story, it's just fascinating.
All right, so where did this game-changing drug even come from? It's not like it just appeared out of thin air. Its discovery really did set a whole new gold standard for how we deal with pain.
I mean, just look at this timeline. Its rise was absolutely meteoric. It was cooked up in a Swedish lab back in 1943, hit the clinics only 5 years later, and then it just took over. Why? Well, because it was faster, it was way more reliable, and it lasted longer than anything else they had at the time.
So what made it so much better? Well, the older anesthetics, the ones called esters, they were kind of fragile. They broke down really easily in the body, and they were much more likely to cause nasty allergic reactions. Lidocaine, on the other hand, was the first of a whole new class called aminoamides. Basically, its chemical structure is just fundamentally stronger and safer. It was a total game changer.
Okay, so how does it actually stop you from feeling pain? This isn't just some vague numbing effect. Oh no, it's a precise, almost elegant act of what you could call molecular sabotage. Let's dive into the science of how it all works. The molecule itself is like this little masterpiece of design. It's got 3 key parts. First, a fatty part that lets it sneak right through a nerve cell's outer wall. Then, it's got a super stable chain in the middle that keeps it from breaking down too fast. And finally, there's a part that loves water, which allows it to get to work once it's inside the cell. It's just perfectly built for its mission. And what is that mission exactly? Well, its one and only target is something called the voltage-gated sodium channel. The easiest way to think of this is as a tiny gate on a nerve cell. When you get hurt, these gates fly open, sodium rushes in, and zap! An electrical pain signal shoots all the way up to your brain. So, here's the crucial part. This is how lidocaine shuts the whole system down. After it slips inside that nerve cell, it goes right up to that sodium gate and physically plugs it shut. It's like a bouncer saying, "Nope, you're not getting in." No sodium can rush in, so no electrical signal can even start. The pain message is stopped dead in its tracks. And what's really cool is that it works best on the nerves that are firing the most rapidly. You know, the ones that are screaming, "Pain!" which makes it incredibly specific. But here's the thing. Just stopping pain signals, that's only half the story. Lidocaine's incredible versatility is what makes it a true medical superstar. This hero wears many, many different hats.
It has 2 really different but equally critical jobs. On one hand, we know it as a local anesthetic, right? Blocking pain in one specific spot. But on the other hand, it's also a powerful antiarrhythmic. Basically, it works on the exact same sodium channels in the heart. So when it's given through an IV, it can calm down the chaotic electrical signals of a dangerous heart rhythm. It literally saves lives by stabilizing a person's heartbeat.
This incredible versatility gives doctors an entire toolkit to work with. You've got topical creams for nerve pain, simple injections for stitches, nerve blocks that can numb an entire arm, epidurals for childbirth, and of course, that IV drip for a cardiac emergency. It's a truly adaptable and essential tool.
Now, like with any really powerful drug, there's always a flip side. Its incredible effectiveness depends on a really delicate balancing act. So it's absolutely crucial for doctors and nurses to understand and respect its potential to be toxic.
So what happens if too much lidocaine gets into the bloodstream? Well, the central nervous system is the first to sound the alarm. And the early warning signs are actually pretty specific. We're talking about a weird metallic taste, ringing in the ears, or a strange tingling feeling around the mouth. Those are the first red flags that the dose might be too high.
And if those early warnings are missed and the levels keep going up, the symptoms can get much, much more dangerous. It can progress to drowsiness and muscle twitching, then to seizures, and in the absolute worst-case scenario, even coma or respiratory arrest. This is exactly why getting the dose right is so critical.
So how do medical pros manage this risk and keep everyone safe? Well, it really comes down to 2 things. Super careful dosing, calculated precisely for each patient, and a little bit of teamwork. Often, lidocaine is paired with a helper molecule called epinephrine.
And this number is key. When you combine lidocaine with epinephrine, the maximum safe dose jumps up to 7 milligrams per kilogram of body weight. So how does that work? Well, the epinephrine actually constricts the blood vessels right where the injection is given. This slows down how fast the lidocaine gets absorbed into the rest of the body, keeping the drug right where it's needed, making the numbing last longer, and dramatically cutting down the risk of it becoming toxic.
So when you put it all together, it's pretty clear that lidocaine is so much more than just a simple numbing agent. It's really a foundational pillar of modern medicine. Its discovery was a massive milestone, and today it is still completely indispensable in everything from dentistry and surgery to cardiology and emergency medicine.
It's really an incredible journey, isn't it? From a little lab in Sweden all the way to a life-saving tool that's used millions of times every single day all over the world. Lidocaine gave us this amazing mastery over acute, localized pain. And that leaves us with one final, really big question. What's going to be the next lidocaine for that vast, complex frontier of chronic pain?